Okay, this video is about what's called sigma notation. So if you look at the top of the notes page, you'll see this labeled mathematical little diagram here. So this symbol here, I'm going to write it to the side so you can see it. It looks kind of like an E is the Greek letter sigma. So that's what you see right here on the problem. So sigma in math is a way that we indicate that you want to sum a bunch of numbers. When we use sigma notation, what goes at the bottom of the sigma is where you start. So this is called the lower limit. So this down here, it's kind of hard to see on my video, but hopefully you can see on your worksheet. This right down here says k equals 1. So that means you start by plugging in a 1 for k. And then at the top, it's the upper limit, which is where you stop. So it says stop at k equals 4. And then inside of the sigma, which would be this thing right here, is a formula that generates the sequence of numbers. So for this particular one, we're just using 2k. So what that sigma means is I want you to add up all the numbers that are generated by this equation 2k, starting with k equals 1 and stopping with k equals 4. So this first 2 comes from plugging in the 1. 2 times 1 is 2. That's the first number. Then you plug in a 2. 2 times 2 is 4. That's the second number. Plug in a 3, you get 6. And then we stop when we plug in a 4. And then, of course, at that point, you could add the number if you wanted to. So if we look down here to this very first example, this says sigma n equals 3 to 5 of n squared. So expanded form of that would mean you plug in a 3 to here. So 3 squared would be 9. The sigma indicates a sum. So then you're going to put plus, and then you plug in a 4. So 4 squared is 16. And a plus, and then you plug in a 5, which would be 25. And then you stop because the upper limit is 5. So this part here is the new stuff, so to speak. Anything else is just kind of a review. So now it says to actually find the sum, so you would just add up those numbers. They add up to 50, and it asks you to determine if those numbers are in an arithmetic, a geometric, or neither pattern, and those happen to be in a neither pattern. Okay, so then what happens when we look at a problem like number 2? So same idea, but the problem here is that the upper limit is 100, and we definitely don't want to write out 100 numbers. So the general rule would go like this. If you're going to put this in expanded form, you're definitely going to put the first term. So I'm going to plug in a 2, plug in a 1. 2 times 1 is 2, plus 3 would be 5. Then I'm going to plug in a 2. 2 times 2 is 4, plus 3 is 7. And then I'm going to plug in a 3. So 2 times 3 is 6, plus 3 is 9. Okay, and then we go like this, plus dot, 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 plus. And then what should go here is the last number. So instead of writing 100, we're just going to write the first 3. Oh, it looks like one of my numbers got erased. Sorry, guys. There's my 9. Plus, dot, 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 plus. And then the last number I'm going to get, which in this case would be t sub 100. So I'm going to plug in 100, and that would be 203. Okay, the reason I want you to write the first 3 is because that's how you need at least 3 terms in order to determine if the series is arithmetic or geometric or neither. So if you only have 2, you can't tell. So you've got to have at least 3 and then the last. Okay, these terms have a common difference of 2. So this is an arithmetic. And then again, this part here is a review. So if you want to find the sum of 100 numbers in an arithmetic series, that formula is n over 2 times t sub 1 plus t sub n. So for our purposes, that would be 100 over 2 times the first term, which is 5, plus the last term, which is 203. And then we would work out that sum, and it turns out to be 10,400. So if I were you, I would pause this video and try 3 and 4. And then when you unpause, I'll have those worked out, and then we'll talk about 5 through 8. Okay, so there are number 3 and number 4 written out so that you can check your answers. On number 3, there's only 6 terms. So I chose to just write the first 3 and the last, but really there's only 2 more terms that I didn't write. So You could definitely have just chosen to write all 6. That would be totally fine. I also chose to use the formula, but again, if you've already written all 6 terms, you could just hand add up those 6 terms with your calculator, of course. And then on number 4, the upper limit on number 4 was infinity. So the same general rule would apply, but there is no last term when it's infinity. So this just says plus dot, dot, dot. And then this is a infinite series, and it's a neither, right? Because the terms are alternating back and forth. And so they're alternating back and forth, but they're not getting multiplied. So there is no sum. Like I can't figure out what the sum is, so the sum does not exist. Okay. Okay, when you go down here to 5 through 8, this is going in reverse. So the series has been written out, and you're supposed to write it in sigma notation. I'm actually going to start with number 6 because, well, just because. So obviously you're going to put a sigma. What goes down here is n equals 1. What goes in here would be the formula that generates those numbers. So you kind of have to go back to the beginning of the unit. This particular case happens to be arithmetic. And it looks like the D is -7. So that formula would be the first term minus 7 times n minus 1. And you are welcome to leave it just like that, or you're welcome to distribute the -7 and combine like terms. The catch is this number here. So what that number is supposed to tell us is the total number of terms that I'm adding up. And I don't know what that is. So we have written the first 4 and then this last term here, but I don't know what the total number of terms is. And so then I'm going to have to find it. So if this is my formula for t sub n, 10 minus 7 times n minus 1, and I know that the nth term is -200, oops, so I'm going to put -200 equals 10 minus 7 times n minus 1. And I'm confident that you guys can solve that equation, so I'm going to just go straight to the answer, which is 31. So this is a 31. Okay, and then again, this part here is not new. This is finding the finite sum, which we did a few class periods ago. So this would be S sub 31, because that's how many terms I have. And that would be 31 over 2 times the first term plus the last term, because it's arithmetic. So once you, again, compute that, you get 2,945. Okay? So for number 5, it would be similar. So I'm going to put my sigma. Okay, obviously this is always going to start at n equals 1. I'm going to determine what type of series this is. So this looks like it's geometric. Everything's getting halved. So it's geometric with r equals a half, but it's also alternating signs. So r is actually equal to -1/2. So the first term is 64, and r would be -1/2 to the n minus 1. And then again, this is usually the part that takes a little more time to figure out. In this particular case, I've already got the first 4 terms. So you could solve an equation like you did over here. I'm going to come down here. So don't mind me. I'm going to come way down here to write this equation. But your equation is going to say 64 times -1/2 to the n minus 1 equals -1/8. And then you're going to have to divide out that 64 and use some logarithms, which you can do. You can also just, if it were me, I would probably just on my calculator start at this -8 and just keep multiplying by -1/2 until I get to -1/8, because it shouldn't be very far. And then you'll end up figuring out that it's the 10th term. You could check that here if you wanted. You can plug in a 10 for the n and then do 64 times -1/2 to the 10 minus 1 and see that it equals -1/8. And then again, the sum is a previous formula. So S sub 10 would equal the first term times 1 minus r, which is -1/2 to the 10th, over 1 minus r. And you would just type this into your calculator, but I would really encourage you to be careful how you type that in, because you definitely need this -1/2 to be in parentheses because it's got an exponent applied to it. So type that in and just make sure you get what I get, which is 42.625. Okay? So again, if you would maybe pause the video and try 7 and 8, and then when you unpause, the answers will be there. All right, there you have it. So number 7 is an infinite series. So the upper limit is an infinity. It was geometric, so you can use your general formula for geometric, which is first term, which is 1/4, times the fourth to the n minus 1, because that was your multiplier. This infinite geometric series does have a sum because r is between -1 and 1. So since my r is 1/4, it will have a sum, and this is the formula. First term, which is t sub 1, over 1 minus r. So your sum should come out to 1/3. Again, this part here is supposed to be review. This part here is supposed to be the new stuff. And then on number 8, this is also a finite. We could just count how many terms there are. There are 7. So the upper limit's 7. And those happen to be the perfect squares. So the formula is just n squared, but that's a neither. And when it's a neither, the only way to find the sum would just be add up all the numbers. So I just added up 1 through 49, or 1, 4, 9, 16, 25, 36, and 49, and you should get 140.